In this problem, we want to determine the values of x for which this equation is true. We want to express our answers as integers or as common or improper fractions. Let me write this a little bit bigger so you can see it. We have 25 raised to the 3x squared plus 5x plus 2.5 power all over 5 equals 1. Alright, so the first thing I'm going to do is I'm going to rewrite 25 as 5 squared. So 5 squared, all of that raised to the 3x squared plus 5x plus 2.5. And in the bottom, I'm going to just write it as 5 to the first. And on the other side, I'm going to write it as 5 to the 0 power, because this is at its heart an exponential problem. Now 1 is the same as 5 to the 0, because any number to the 0 power is just 1. But I'm going to use 5 because 5 is the common base here. Now when you have an exponent on top of another exponent, you multiply them. So you have 5 to the 6x squared plus 10x plus 5 all over 5 to the first equals 5 to the 0. Now when you have when you're dividing two expressions with exponents and they have the same base, you subtract the exponents. So that means we have 5 to the 6x squared plus 10x plus 4, because we subtract 1 from 5, and that equals 5 to the 0 power. So now, these two quantities are equal, and their bases are equal, so therefore the powers are equal. So that means 6x squared plus 10x plus 4 equals 0. So we have a quadratic. Now we can factor out a 2, so 3x squared plus 5x plus 2 equals 0. Now you can use quadratic formula, or if you know how to factor this, it's going to factor like this. 3x squared breaks into 3x and x. Now 2 can either be 2 and 1 or negative 2, negative 1. But we know because the middle term is positive, they both have to be positive. And the way it's going to work is it's going to be plus 2 here and plus 1 over here. So that means 3x plus 2 equals 0, and x plus 1 equals 0. So that means x equals negative 2/3, and x equals negative 1. So both of these are our answers. And we're done.